Alright, there are two sub-objectives in section 4.2. The first one is to add and subtract rational expressions. And the second one is to simplify complex rational expressions. So a rational expression is any polynomial over another polynomial. So x squared minus 1 over x plus 2. Anything that looks like a polynomial over another polynomial, that's a rational expression. So notice we're not trying to solve anything because we're working with expressions. All we do with expressions is add, subtract, multiply, divide, and simplify. We don't solve. Okay, so the first problems are to add or subtract rational expressions, and we need a common denominator to be able to do this. So let's just have a little conversation about common denominators. If I have two numbers like 12 and 18, the least common denominator or lowest common denominator, smallest common denominator, all those mean the same thing, is going to be the smallest number that both of these numbers divide into evenly. Well, there's a way to figure that out, and it involves factoring the two numbers. So 12 is 2 times 6, which is 2 times 3. 18 is 2 times 9, which is 3 times 3. So the lowest common denominator needs to be at least as big as the biggest number, and then if there are any factors missing, they need to be included. So I have 1 3 included, so I have this 3 included. And I have 1 2 included, so I have this 2 included, but I don't have this 2 included. So 18 times 2, or 36, is going to be the smallest number that both of those numbers divide into evenly. So then the other thing that you could ask to do with pairs of numbers is to find the greatest common factor. So that's asking you about what is the biggest number that will divide evenly into both of these numbers. And again, it can be as big as 12, but it can't be any bigger than that, or it won't divide evenly into 12. So again, let's look at the factors. 2 times 2 times 3, and 2 times 3 times 3. Well, this least common multiple is actually called the union of the two sets of factors. It's a list of all of them, but don't repeat duplicates. So now we want to know what is the overlap between these two sets of factors. And so I see that they have in common a 2 times a 3. So 6 is the biggest number that will divide evenly, which is 12 and 18. So when we're talking about common denominators, we're looking for this. We're looking for the smallest thing that both divide into evenly. It has to be at least as big as the biggest thing. So in this case, I have 4y. Well, the 2 on the x will already divide evenly into the y, so the only other thing I need is a factor of an x. And now 2x divides evenly into this, and 4y divides evenly into this. So this is my least common multiple or lowest common denominator, whatever you use. Okay, so for the first denominator, I have a 2 and I have an x, so I need another factor of a 2 and I need a factor of a y. So I need to multiply the denominator by 2y in order to get my common denominator. So I must also multiply the numerator by 2y to make sure I'm multiplying by 1. Because multiplying by 1 doesn't change anything, so that's a legal algebra maneuver. So then the next denominator has the 4 and the y in it, but it needs an x. So you need an x in the denominator to have the common denominator. So you need an x in the numerator. Make sure we're multiplying by 1 and not changing anything, just making it so we can add. So I'm going to combine the numerators over the common denominator, and this is our final answer. If we attempted to cancel those 4s, Don't do it! The plus makes it so that you can't do that. But this is your problem. Okay, so the next one, you need to always see if you can factor denominators. And this one looks like it factors, the trinomial factors to two binomials, x minus 2 times x minus 1. So I see that for the first rational expression, I don't need anything more to have the common denominator, but the second guy needs an additional factor of x minus 1. So now they have a common denominator. I can combine the denominators over the combine the numerators over the single denominator. So 4 minus 2 times x minus 1 over x minus 2 times x minus 1. And then you need to simplify that numerator because there could be like terms hiding in there. So we need to look and see if there are. So we have 4 minus 2x plus 2 over x minus 2, x minus 1. So you see there are like terms. So typically you write the terms with x's first and a constant last. And then we have our denominator. And then if you want to make this look even more beautiful, you could factor out the negative 2. And remember, when you're factoring out a negative to be super careful. And make sure that when you distribute, you get back to what you started. So this is in factored form. And I prefer factored form. It's simpler. So in general, factored is simpler. And Newton was smart enough that it could accept either. Okay, now the next example, the denominators have nothing in common. So I just have to multiply the first fraction by the y plus 1 over the y plus 1 to get the common denominator. And the second one by x minus 2 over x minus 2. So that's going to give me, distribute 8y plus 8 plus 4x minus 8 over x minus 2 y plus 1. Well, that's nice. The 8 cancel. And we have a factor of a 4. So we're going to factor out the common factor of 4. And we get 4 times x plus 2y over x minus 2 y plus 4. Okay, so then let's look at D. And we should look and see if there's any way we can factor this denominator. And it looks to me like that trinomial will factor to the two binomials x plus 5 times x minus 2. So the common denominator is going to be the whole first denominator, x plus 5 times x minus 3. And then it's going to be minus 3 over the factor of the x plus 5. So now I need an x minus 3 over x minus 3 in order to have a common denominator. Okay, so now I'm going to combine the numerators over the common denominator. 7 minus 3x plus 9 plus 5x minus 3, so negative 3x plus 16 over x plus 5 and x minus 3. So that's all the examples for add and subtract rational expressions. Now these next problems are called complex rational expressions, When you have a lot of fraction bars in one problem, that's what the word complex is referring to. We have a fraction bar here, a fraction bar here, a fraction bar here, and you never leave your final answer to a problem is a complex fraction. You always need to simplify your complex fraction because you have only one fraction bar. So I'm going to show you two different ways to do this. I'm going to start with my preferred way. I look at all the fractions in the fraction and look at the denominators, and I see that I have a denominator of x. So I'm going to multiply the numerator and the denominator by that denominator I'm seeing of x, and I'm going to distribute the x to each term of the numerator and each term of the denominator. So the numerator, I'm going to get 8x, and then the x's are going to cancel in the second term. And then 4x minus, and the x's are going to cancel in the second term. So I like this way because it seems like it gets to the answer quicker. So let me show you, there is another way. So you can just work on the numerator first. Okay, I want to get the numerator so that it has a common denominator. And we have 8 over 1 times x over x plus 1 over x. So 3x plus 1 over x. And then I'm going to look at the denominator, get it over a common denominator. So we have 4 times x over x minus 1 over x. So that's going to be 4x minus 1 over x. And then divide. So I have 8x plus 1 over x over 4x minus 1 over x. And notice I made a big fraction mark so that we really see what's dividing what. There's a lot of fraction bars there. Okay? And then remember that dividing by a fraction is the same thing as multiplying by the reciprocal. And these x's are going to cancel, and we get the same answer. So to me, that seems a lot more. And then the second example, again, I would look and say, oh, there's a denominator of an x minus 2. So I'm going to multiply the numerator and the denominator by x minus 2. And again, this is 1, so we're allowed to do that. So in my numerator, if I FOIL that out, I'm going to get x squared minus 5x plus 6. And then I'm going to distribute x minus 2 to x. And then x minus 2 to negative 3 over x minus 2. That's going to give me negative 3. That's minus 3. Okay, so actually really factor that out in the numerator. I want to make sure that I find any common factors, so I'm going to factor so I can find them easier. So I have x squared minus 2x minus 3. Well, I'm pretty sure that's factor. Let's see. And I always check my factor. I don't think something works. So your final answer is going to be x minus 2 over x plus 11. So the other way of doing it would be to simplify the denominator. Okay, let me just work on the denominator first. I have x minus 3 over x minus 2. And you get that over a common denominator. So that's going to be x squared minus 2x minus 3 over this common denominator. Then I'm going to need to do the division problem. Then divide. And notice I'm giving you a few words to help you follow through my work. So divide x minus 3 over x squared minus 2x minus 3 over x minus 2. Remembering that to divide by a fraction, you multiply by the reciprocal. And now I have x minus 3 times x minus 2. And I notice again that I can factor the denominator, and I get this one. Okay, then C, again we're looking for a common denominator, so that I can multiply the top and the bottom by a common denominator. I see an x minus 2, and then I see an x squared minus 4, but I remember that that factors as a difference of squares. So this is my lowest common denominator. So I'm going to multiply the numerator and denominator by this common denominator of x plus 2, x minus 2 divided by x plus 2, x minus 2. So I'm going to distribute to each of the two terms in the numerator, and distribute each of the two terms in the denominator. Okay, so when I distribute to the first term, the x minus 2 will cancel, and I'll have x times x plus 2 plus, we don't have this x plus 2, x minus 2, over 3 plus x plus 2x minus 2. Now I need to simplify the numerator and simplify the denominator separately before I look to see if there are any common factors. So x squared plus 2x, so I can multiply this back together so I can see if there's common terms. And I'll have 3 plus x squared minus 4. So it looks like I have 2x squared plus 2x minus 4 over x squared minus 1. So I'm seeing a common factor of 2 in my numerator. So I'm going to factor out the GCF. I see that my denominator factors as a difference of squares. And my numerator factors to x plus 2, x minus 1. And then over x plus 2, x minus 1. Now these exponentials can cancel because they're matching factors. So my final answer is 2 times x plus 2 over x plus 1. And that's what I have for you for 4 points.